Okay, so this is Unit 1, Lecture 2, Part 2. This will not take very long. I just want to make sure that you have an example of one of these more difficult problems because they will come up, and this way you can review them whenever you want. All right, so before we move to the hard example, I want to make sure that you understand this part. So it's super, super important, underline this, to determine whether or not an object is accelerating before you start the problem. If you don't do that, you're going to waste time trying to figure out variables. You're going to be confused. It's going to be frustrating. Okay, so you have to figure that out first. Key things to look for would be if you see the words constant velocity, or if you see anything saying that the speed changes, those would tell you one way or the other. Remember that in constant velocity, the variables list is very simple. You have velocity, displacement, time. That's it. Okay. If something is accelerating, you have final velocity, initial velocity, acceleration, time, and displacement. Okay, so it's very different lists. So you need to remember that. All right, now, here's another important piece. We are going to stop before we get to this group activity. You're going to do that part in class, okay? So we're just going to do this example. Anytime an object's acceleration changes, you must solve it as a separate problem, okay? And you're going to see that happen here, and this is very, very, very important. Okay, let's make sure we're in focus here. Okay. All right, example. A car starts from rest. Let's write down these things that we're finding out as we find them out. Initial velocity is 0 anytime you see that a car starts from rest. And accelerates at 3 meters per second squared for 10 seconds. So accelerates at 3 meters per second squared for 10 seconds. Okay. Then continues at a constant velocity for the next 30 seconds. So right there, the acceleration changed. First, it was accelerating at 3 meters per second squared. Then it was going at a constant velocity. So that means the acceleration would be 0. So let's note up here, this means acceleration equals 0. Okay. So because the acceleration changed, we're going to have part 1 and part 2 in this problem. Okay, so we're going to start, this is part 1. And part 2, we have a constant velocity, which means our variables are v, d, and t. Okay. In part 1, we have acceleration, so we have v naught, or v initial, a, t, vf, and d. Okay. So let's work on part 1 here. We want to know how far the car traveled, total, with both parts. Okay. So we're going to have to find d for both parts. So we can do that in part 1, and the way that we would do that is we would look at what we have. We don't have v final, and we're not looking for it right now. We're just looking for the displacement. So we want to find the equation that does not have v final in it, okay? And that would be equation 3. So that's the one I'm going to use. So I'm going to say d equals initial velocity times t plus 1/2 at squared, okay? We know the initial is 0, so this whole piece goes to nothing, right? 0 times anything. Plus 1/2 3 times 10 squared. Okay, and when we do that piece, we go ahead and we get the displacement to equal 150 meters. Okay, so that's not our final answer, but let's make sure we remember that that's there. Okay. Now, for part 2, all that we know is that we're going to go for a total of 30 seconds. We don't know the displacement, that's what we're looking for, and we don't know the velocity. This is the tricky part. The car starts from rest and accelerates for 10 seconds at 3 meters per second squared. After 10 seconds, it continues at that constant velocity for the next 30 seconds. So the velocity for part 2 is whatever velocity we finished with in part 1. So the key is that we find the final velocity in part 1, and that becomes our constant velocity in part 2. Okay? So in order to find the final velocity, we can use any of the equations that we want because we have all the variables. This looks like the easiest one to me, so that's the one I'm going to use, is the first one. So I'm going to use VF equals V naught plus AT, and when I plug in, I'm going to get 0 plus 3 times 10. And so you can see that the final velocity here would be 30 meters per second. Just kind of squeeze that in. Okay. And then that becomes the constant velocity for part 2. Now part 2, there's no decision to make about equation because there's only one equation for constant velocity. So we plug into that. So 30 equals d over 30. Did I do that right? Yes, I did. Okay, so then d becomes 30 times 30, right? Because we have to multiply 30 to both sides, and we get 900 meters. Okay. Now that's not our final answer. I know that seems like a lot of work and it should be done, but remember we want the total distance for the whole thing. So we have the 150 from part 1 and the 900 from part 2. So the total displacement would be 150 plus 900. And so we'd get 1,050 meters as our total displacement. Okay. If that was confusing to you, make sure you go back, watch it again, make sure you understand it. If you don't, make sure you come to collaboration, ask me about it, and we can go through some of those details. Okay. We will be doing a warm-up that will help kind of get these ideas in your head, but that's what you have for now. We'll do the group activity in class. Okay. See you in class.